All right, my friends, let us begin to find the inverse of fractional exponents, all right? Now, this looks kind of tricky because it's 2/5, and you might ask yourself what kind of shape it makes. Well, the one thing you can really just focus on is the exponent on the top here of your fraction, your numerator, the 2, because it's squared, okay? That means, all right, remember the number on the bottom, for example, okay, let's look at something like this, 8 raised to the 2/3. Okay, the number on the bottom of your fraction says what three numbers multiply, or what number raised to the third power gives you 8. Well, the answer is 2, right? So this would be 2, and now this has a 2 on top, so 2 squared, which is going to be 2 squared, which is going to be 4. All right, that's basically what it means. Well, let's take a look at one more example problem. Let's say we got -8 raised to the 2/3. Again, okay, this says what three number multiplied 3 times gives you a -8. Well, that's just -2, because -2 times -2 is +4, but you multiply a -2 again, and that's going to give you the -8. All right, so the number on the bottom is not going to influence much. You're going to have to look at the number on the numerator of the fraction, because you know it's going to take it and it's going to square, right? We ended up getting, when we did this, we knew our answer was -2, so we get -2. But now that we took care of this, right, this becomes -2. What three numbers multiply? Well, 3 times by themselves to get you -8, that's -2. But we still have this squared. And what's -2 squared? That's +4. So you'll see the number on the numerator will square. If it's even, it's gonna take a negative number and turn it positive. So you should expect it, okay? So I did all this process because you should expect this, my friend, to make some kind of U-shaped. Okay, not 100% of a U, but something similar. Well, x plus 5 means you move to the left, -5, and -4 means you move down. So you should expect your function, I don't know, it's going to make some kind of U or some different kind of shape to do something maybe like this. Maybe more of like a bird, you know, something like that. Okay, and here is, I already graphed it for us. Right? 3 times x plus 5 raised to the 2/5 -4. And if we go to graph this, will look very similar. Does kind of make a U shape, so you know you're going to need a plus or minus. All right, and that's kind of the lesson. If you have an even number up here, 2, 4, 6, 8, you know it's going to make some kind of U shape, bird shape, and you're going to need the plus or minus. So how do we solve this? Well, y equals 3 times x plus 5 raised to the 2/5 -4. Instead of writing f of x, we like to write y. Let's go ahead and switch our x and our y, and I'll go ahead and switch colors for you so that you can stay entertained. 2/5 -4, my friend. Oops, hold on, let me just backtrack. We switched the x and the y, and I got too excited. I forgot to put a y here. Okay, y plus 5 raised to the 2/5 -4. Okay. Well, now just like before, the inverse does the exact opposite, so we're just going to add 4 to both sides. And we're going to get x plus 4 is equal to 3 times y plus 5, all raised to the 2/5. Okay, what do you do to get rid of the multiplication by 3? Well, you divide by 3. Okay, again, you can divide each of these individually, but I guess in this video I won't do that. I'll just leave it like this, just to show you that there's flexibility. Okay, all right, now we want to get rid of the 2/5, and maybe that's the part that you'll get stumped and you're like, I'm not sure what to do. Well, my friends, it's not too bad. Look at it like this. We got 2/5, right? We want to multiply this by a fraction so that our answer is just 1. That's when something cancels out, you're essentially going to get 1. Well, what do you need up here to cancel out with the 5? Well, you want these to cancel, so you know this has to be a 5. Because then these are going to, 5 divided by 5 is 1. And then what do you need on the bottom then? Well, you're going to need a 2, because then 2 divided by 2 is 1. 5 divided by 5, and we're going to be left with 1. Okay. So essentially, you just multiply the exponents by the opposite operation that you saw there. So this is 2/5. It'll become 5/2, right? Which is this right here. Because you know it's going to make this kind of U shape, you know you're going to need a plus or minus. Okay, 5 divided by 5 is gone, 2 divided by 2 is gone, so we get plus or minus. We got x plus 4 all divided by 3 raised to the 5/2 is equal to y plus 5. Last but not least, all we got to do now is just subtract 5 and continue on, my friends, and we will be in show business. X plus 4 raised to the third raised to the 5 over 2. Remember, this is stuck inside. It is stuck in its prison, and this minus 5 cannot go inside. So we have to just subtract the 5 on the outside. Is equal to y, and there it is, the inverse of a fractional function. Okay. Let's look at one more. F of x is equal to, let's do x plus 1 raised to the 3 over 8. 3 over 8 divided by 2 plus 3. Okay. So let's go ahead and type that in and see how it looks like. But I want to show you, okay, it's what is the number on the numerator, an even or odd exponent? Well, the 3 is odd, so it's not going to make a U shape. You should expect this function to make some other kind of shape, but it's not going to be a U, maybe something like a saddle. Okay, so let's go ahead and just take a look at it real quick. I'm just going to put the 1/2 on the front real quick, just because, you know, with these calculators, kind of weird. That's the 1/2 here is really just this dividing by 2. Then we're going to get x plus 1 raised to the, I'll put some parentheses, 3 divided by 8 plus 3. Let's go ahead and hit the graph. All right, there it is, right? Doesn't really make a saddle. It's making more of like a square root function. Which is to be expected when you're dealing with fractional exponents, right? Because remember, if you were to graph something like something to the 1/2 or the 1/3, it'd be a square root function. That's why it's important to graph these. If you know it's even on the numerator, then you know for a fact you're going to get 2 answers. But plus or minus. But because it's odd, you don't need to put the plus or minus, because when your function gets it, it's just reflecting, and you're just going to get that little line there. So what do? We switch it. Y equal, let's write, instead of f of x, we'll do y equals x plus 1 raised to the 3 over 8, all divided by 2 plus 3. Okay, we're going to switch the x and the y value. So we're going to get y plus 1, all divided by 2, raised to the 3 over 8 plus 3. Now we just undo order of operations. I'm going to switch colors because I like to, and we're going to subtract 3 to both sides. Boom, 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 wow. X minus 3 is equal to y plus 1 raised to the 3 over 8, all divided by 2. Well, what do we do to get rid of the division by 2? We multiply by 2 to both sides. And when I multiply 2 to both sides, I like to put a set of parentheses there. Boom, boom, gone. Okay, let's go ahead and just distribute this across. We're going to get 2x minus 6. 2 times x is 2x. 2 times negative 3 is a negative 6, my friends. And we are left with y plus 1 raised to the 3 over 8. Okay. Again, maybe the hard part is figuring out what exactly do we need to multiply on the exponents so that they cancel out. Well, let's go over here. 3 over 8 times. Remember, we should get 1. So what needs to go up here? Well, it has to be an 8 so that these cancel. And we need a 3 in the bottom so that these cancel. So it's just the opposite. 8 over 3. And you don't need a plus or minus because it's not, our original function did not have an even exponent on the numerator. Cancel, cancel. We're left with 2x minus 6 raised to the 8 over 3 is equal to y plus 1. And all that's left to do now is just subtract 1, my friends, and you're done. We are finished. We're going to get 2x minus 6 raised to the 8 over 3 minus 1 is equal to y. And there is our inverse. Okay. Hopefully you understand fractional exponents better, my friends. I think that was one pretty awesome lesson.